the United States implemented strong sanctions. These sanctions aimed to slow China's technological progress. Specifically, they targeted China's growing semiconductor industry. The goal was clear: prevent China from accessing advanced chip-making technology. Washington worried about China's military modernization and economic competition. Many believed they would severely cripple China's ambitions in high-tech sectors. However, these measures have produced some unexpected results. Instead of collapsing, China's domestic chip industry has shown remarkable resilience. The sanctions appear to have acted as a powerful catalyst. They spurred an unprecedented drive for self-sufficiency within China. The Chinese government and private companies mobilized vast resources. This national effort has begun to yield tangible results. It demonstrates a strong determination to develop indigenous technological capabilities. The story is no longer just about restriction, it is about adaptation and surprising growth. Measures designed to curb China's tech ascent may be accelerating it in certain ways. While access to the most cutting-edge global technology is still restricted, China is making strides. It is focusing on mature and less advanced chip production. It is also investing heavily in research for future breakthroughs. This has significant implications for the global semiconductor supply chain. The landscape is shifting in ways few predicted just a few years ago. The future trajectory of semiconductors is being redrawn by these events, with lasting consequences for all. The United States initiated export controls targeting China's semiconductor technology. The aim was to hinder China's advanced chip production. These chips power modern electronics and military systems. National security was a key concern. Officials worried about enhancing China's military capabilities. The entity list was a major tool. Huawei was an early addition. The US influenced allies like the Netherlands and Japan. Sanctions disrupted Chinese tech firms. Faced with stringent US sanctions, China did not capitulate. Instead, the nation embarked on an ambitious mission. This mission was to achieve semiconductor self-sufficiency. The Chinese government framed this as a critical national priority. Billions of dollars were pledged in state-led investment funds. These funds were directed towards bolstering domestic chip design, manufacturing, and research. The scale of this financial commitment is immense. It reflects the strategic importance China places on overcoming the US restrictions. A core component of China's strategy is the Made in China 2025 initiative. This plan aims to increase the domestic content of core materials and components. For chips, the goal was to significantly reduce reliance on foreign technology. Local governments across China also launched their own subsidy programs. They offered incentives to attract semiconductor companies and talent. This created a nationwide push to build new fabrication plants or fabs and research centers. The effort is a coordinated national campaign. This drive for self-reliance has led to a surge in domestic chip production. While China still lags in the most advanced chip nodes, it is rapidly expanding capacity in mature process technologies. By focusing on these segments, Chinese companies can meet significant domestic demand. They can also gain experience and revenue. This revenue can then be reinvested into research for more advanced technologies. Semiconductor Manufacturing International Corporation, or SMIC, is China's largest chip foundry. It has become a focal point of China's efforts to build a domestic semiconductor industry. Despite being placed on the US entity list, SMIC has continued its operations. It has also made notable progress in certain areas. The company has focused on developing mature process nodes. These are crucial for a wide range of electronic devices. While it faces restrictions on accessing the most advanced extreme ultraviolet EUV lithography equipment, SMIC has adapted. It works to optimize existing deep ultraviolet DUV lithography tools. SMIC has reportedly made breakthroughs in less advanced yet still significant chip manufacturing processes. For example, there have been reports of SMIC producing 7-nanometer chips. This was achieved using existing DUV equipment, a considerable technical feat. While the yield and volume might not match global leaders like TSMC, it demonstrates growing capability. These chips are believed to be used in some domestically produced devices. This reduces reliance on foreign foundries for certain applications. SMIC's progress, even under sanctions, sends a signal of China's resilience. The Chinese government has provided substantial support to SMIC. This support is critical for SMIC to continue its research and development efforts. Huawei, once a global smartphone leader, was severely impacted by US sanctions. The restrictions cut off its access to advanced chips from suppliers like TSMC. It also lost access to Google's mobile services for its international phone models. This dealt a significant blow to its consumer business. Many observers predicted a rapid decline for the tech giant. However, Huawei has demonstrated remarkable resilience and a strong will to adapt. The company has reoriented its strategy. It focuses on new business areas and invests heavily in research and development, particularly in chip design. A key part of Huawei's response has been its high-silicon chip design division. Despite being unable to have its most advanced designs manufactured by leading foundries, HiSilicon continues its work. Huawei has reportedly made progress in developing its own chip design tools. It is also exploring alternative materials and architectures. The company surprised many in 2023. It launched a new smartphone, the Mate 60 Pro. This phone featured a domestically produced 7nm Kirin processor, reportedly manufactured by SMIC. This was a significant statement of its capabilities. Beyond smartphones, Huawei is diversifying its portfolio. It is expanding into areas like cloud computing, smart city solutions, and automotive technology. Taiwanese companies, particularly TSMC, are central to the global semiconductor industry. TSMC is the world's largest contract chip manufacturer. It produces the most advanced chips for companies like Apple, Nvidia, and Qualcomm. The US-China tech rivalry has placed Taiwanese suppliers in a difficult position. On one hand, the US is a key partner and market. On the other, mainland China has historically been a significant customer and manufacturing base for some Taiwanese firms. Navigating these competing pressures requires careful strategic maneuvering. US sanctions on China have directly impacted Taiwanese suppliers. They are largely compliant with US export controls. This means they have stopped supplying advanced chips to sanctioned Chinese entities like Huawei. This has led to a loss of business from some major Chinese clients. However, the global demand for advanced semiconductors remains incredibly strong. Taiwanese foundries like TSMC are operating at full capacity to meet orders from US and other international customers. The shift in orders has in some ways reinforced their importance to the Western tech ecosystem. In response to the changing geopolitical landscape, Taiwanese companies are adapting their strategies. One key adaptation is diversification of manufacturing locations. TSMC, for instance, is building new fabs in the United States and Japan. This move is partly driven by customer demand for more resilient supply chains. It is also encouraged by government subsidies in these countries. The US sanctions against China's chip industry have sent ripples across the global technology sector. These actions have altered supply chain dynamics and intensified geopolitical competition. One major consequence has been an increased focus on supply chain resilience. Countries and companies are diversifying their sources of critical components. This has led to new investments in chip manufacturing facilities globally. The ongoing US-China tech rivalry, particularly in semiconductors, raises a significant concern. This concern is the potential for technological bifurcation. This means the world could split into two distinct and largely separate technology ecosystems. One ecosystem would be centered around the United States and its allies. The other would be centered around China and its partners. Each ecosystem might develop its own technical standards, supply chains, and dominant companies. This would represent a fundamental shift from the largely globalized tech industry of the past few decades. If such a bifurcation occurs, it would have profound implications. Companies might be forced to choose sides. They might need to develop different product versions for different markets. This would increase costs and reduce efficiencies. Innovation could also be affected. Collaboration across these two spheres might become difficult or impossible. This could slow down the overall pace of technological progress. Consumers might face less choice and potentially higher prices. The free flow of data and digital services across borders could also be significantly restricted. There are already signs pointing towards a possible decoupling in certain tech areas. China is actively working to replace foreign technology with domestic alternatives in its critical infrastructure. The US sanctions have undeniably reshaped the global semiconductor industry. The initial intent was to curb China's technological advancement. China's domestic chip industry has shown unexpected resilience and growth. Companies like SMIC and Huawei are making notable progress. Taiwanese suppliers are adapting skillfully. The trajectory of the semiconductor industry will be heavily influenced by geopolitics. The story of the semiconductor industry is far from over. A new chapter is being written.